We work on experiments all the time at the Louis Armstrong Middle School. We have recorded some of our experiments for students to review. Okay, in this third class lever, we're trying to see whether or not the effort placed at different places away from the fulcrum is going to have an effect on how much effort is needed to lift the load. We know it's a third class lever because the effort is in the middle. The fulcrum is on one end and the load is on the other. Okay, we're using a spring scale that measures to 5,000 grams to begin with, and we have our effort 2.5 or 2.5 centimeters away from the fulcrum, and we're going to try to lift this right now. Okay, Derek, lift. Okay, this is taking a monstrous amount of effort to do. This load weighs 240 grams, and it's taking 3,500 grams of force to lift this off the table. 240 grams is taking 3,500 grams of force. That's pretty nice. Okay, so now we're going to put this down, and we're going to move the effort to 15 centimeters away from the fulcrum. I'm going to move it to 15 or 10 centimeters away from the fulcrum. Okay, we're going to try it again. Put the load back on. Okay, and at 10 centimeters away, it's taking 1,500 grams of force to lift a 240 gram mass. And Andrew's holding the ring stand to the table because it'll move all over if he doesn't do that. Okay, now we're going to move the effort to 15 centimeters away from the fulcrum. And it is now taking 1,000 grams of force to lift the 240 gram mass. Okay. Now let's see what happens if we go to halfway in between. So at halfway in between, it's 500 grams of mass to lift the 240 gram, or it's 500 grams of force to lift the 240 gram load. And now let's go to 10 centimeters away from our load. And at 10 centimeters away from our load, we're at about 250 grams of force are needed to lift 250 grams, which is our load.